And let me just go through the note well. So I'm looking at the list. Most everybody has been here and participated in the IETF. So I'm presuming you're well aware of our note well and IETF policies with respect to participation. With that, with the agenda, I wanted to take 5 minutes to do the bashing and to remind everyone that we are recording the session. There is a Jabber room. Given that we do have a Jabber room, is there anybody that's willing to help us monitor that and channel whoever's in the Jabber room if they have questions? Anyone?
Nancy, I am logged into the Jabber room, so if someone asks something and it's not answered, I'll try and keep an eye on it.
Okay. And given that we do get into discussions, I thought I would ask if I think it worked really well during the virtual sessions last week where we had a running queue. For those who may not be familiar, what happened last week was anybody who wanted to speak during each of the presentations would, rather than speaking, would put themselves in the queue in the chat room by doing a plus Q. If they didn't want to be in the queue or be removed from the queue, they would put a minus P.
So Nancy, it might be useful to clarify, it's the WebEx chat room.
Thank you. It is the WebEx chat room. Thank you for that, Roman. So if I'm not hearing disagreement, thank you. So if you want to ask a question or make a comment, please put yourself on the queue. Ned, Kathleen is not going to be able to join us today. Do you mind running the queue?
I'm happy to do that.
Thank you. Okay, so with that, we have in the agenda today, we've got Michael to give us an update on the architecture draft, Lawrence on the EAT plane characteristics. Lawrence, in the discussion here, I wanted to find out when you think you can put an update to the draft, because I noticed the last update was done in February. Then Eric will talk about the timing definitions that's being discussed in the architecture, followed with Lawrence's discussion also on the timestamps, followed by a new draft that was posted by Eric on trusted path routing, and then Wei Pang on the PubSub.
Nancy, before we jump into this, can we see if we can get a second Etherpad note taker?
I was just about to say,
Okay.
we need a.
I will help after I talk.
Thanks, Michael. And then anybody who's overlooking the Etherpad, please feel free to also help and annotate with that. The other process that we're following is please look at the Etherpad. We're running the blue sheets in the Etherpad, so add your name there to make sure that we capture everybody who's participating. Any comments or issues on the agenda? Okay, hearing none, let's go ahead and get started. So Michael, I have your architecture slides here. Why did it not go to the beginning?
Okay, so are you going to exchange Eric and Lawrence? Are you?
I thought I did. So Lawrence is going to talk about the claims first. Then Eric is going to talk about the timing. Did you want me to change the order?
I'm sorry, is that what that was the correct order?
Yes, looks good to me.
Yes.
All right. Thought that was the wrong order.
No, this was the requested order.
Okay, yeah, I'm sorry, I'm ready to start.
Okay, I'm trying to figure out why it's not going to the beginning. There we go.
Push up arrow. Okay. Great. So my screen copy. Okay, so, and maybe
Please
people could be
mute.
on mute. Patrick, maybe that was. Hi, this is Michael Richardson. So there has been a approximately weekly or more often design team meeting for the architecture draft. And we have mostly met on Tuesday mornings at 10 a.m. EST with a couple other Fridays and some other ad hoc meetings that were added to get work finished. That list alphabetically is my, I hope, collection of everyone that I've seen show up. Stars next to those who are authors, and we added Wei Pan as an author in early February. Next slide, please. So I'm going to go through walk through the architecture, talk a little bit about the table of contents, the open issues, which is of course changing. It's changed since I made the slide, and basically what we've done since the last meeting and what it looks like. Next slide, please. And I'd be very happy to take questions as we go, but I have left a chunk of time at the end to deal with questions of a more general nature. So this is the table of contents as it looks now. You can see we have added 6 major use cases. We've had conversations about adding more, but at this point, we think that this pretty much covers the high level of pretty much all of the situations. We still think that there are details of this, and one of the things I believe Ned and some other people have suggested different terms. One of them is protocol, and when you describe a particular use case and how it's used, that it's actually a particular protocol because there's a conveyance and a whole bunch of other things that are involved, and the architecture doesn't deal with that. Number 9, freshness is subject of a discussion with Lawrence and Eric. This is what's become timing. And how do we measure freshness? So I'm not going to delve into that a great deal in that part. And I don't think there'll be a major change in the table of contents as we go forward. But if there is some particular thing that you want to discuss in there about the overview of the architecture, that would be a reasonable question. Next slide. Next slide. So, no, sorry, go back one. Slide 4.
This is slide 4.
Okay, thank you. Just there's a delay.
Sorry.
So these are some links to the open issues, at least as of Friday morning-ish. There have been some 1 or 2 closed since and 1 or 2 open. In general, we try to collect concerns that we may have as issues, which we then wind up having pull requests to change the text, or sometimes it's just a pull request. Here's some text. Anyone is welcome to comment, to review, and we'd be very much interested in what's going on. You can see the numbers are up in the 60s. We've closed quite a number of issues as we've gone forward. And there's maybe 1 or 2 issues that we will perhaps never agree on, and there are some issues that, should we have a claims terminology, which is almost a bike shed. Next slide. Since last time, you may have seen the slide from before. We have extensively argued and created an introduction. We've reworked the terminology discussion, and it's pretty much done. We realized that the word claim was not in it, and then wondered whether we needed to define it. And we actually did some research in other RFCs that do define the word claim, thinking none of them actually None of them actually defined it, but that was not the case. Published 02 just before, well, I guess it was published with the, published at the deadline, which then became not a deadline. And we will publish another one soon. Next slide. So conceptually, we drew this 3-box, a tester, verifier, and relying party flow. This is generically what happens. There's evidence that moves from the attester to the verifier, and there's attestation results that move to the relying party. And then having written that flow, we realized that there was a bunch of things we needed that also were important that we needed to define, which is the endorsements from the endorser, an appraisal policy, and an appraisal policy for the attestation results for the relying party. So those are in the blue, pink, and purple boxes if you're not colorblind. And the important thing to realize is that none of these are currently in the charter for the current IETF RATS working group. It's possible that they will never be in scope for the charter, or it's possible the working group will get rechartered to include one of or more of these items. But at present, these are external things, and while we can discuss the properties, we're not talking about how to standardize those. The way specifically that the attester, verifying, relying party operate, and the things that they emit being evidence and attestation results are directly within the RATS charter, and the architecture speaks about the properties and the activities of each. Next slide, please. So we realize there's 2 types of environments. There's a target environment, which is the thing that we are trying to say something about, and there's the testing environment, which is the thing that does the evaluation or the measurements. Next slide, please. Someone's got a lot of static coming in. Patrick, maybe you could mute, because that's what's telling me, or someone could mute Patrick, you either. Thank you.
I'm on it. He's muted.
Yeah. So the target environment, we have had some interesting conversations where some people said there are some use cases where the target environment and the testing environment are the same thing. And in fact, that the suggestion is that there's some cases where it will measure itself. Next slide. So some people ask the question, can any object be trusted properly to measure itself? Can those measurements be trusted if you are doing that self? Next slide. And so we have agreed to the statement that, yes, this is possible for them to be in a single environment, but it's up to the verifier to decide if this makes sense. And so while there's a lot of environments where this would be an untrustworthy kind of thing, ultimately the verifier is what decides this. Next slide. There's a question.
Oh, keep going.
Next one. You went one too far. There was one more bubble. That's okay.
It is slide
On that
11.
question, register yourself in the queue, and we know.
So we have this concept called layered attestation. And many of you are familiar with this in the form of trusted boot, where there is a one piece of code which runs, which measures the next piece of code, provides evidence for it, and this goes on. And we've illustrated 3 layers in this case. Next slide, please. And so, for instance, the first layer is often the UEFI BIOS firmware. Next slide, please. The next environment is often some rich execution environment, as the people call it, you know, some operating system, something else, some kernel and pieces like that. Next slide, please. And an example of a third layer is maybe there's some target applications that are measured, or a configuration or a set of processes. These layers are not strict. You could have 2 or 7. That's irrelevant to the thing, and you can throw them in different ways. These are just examples of some things. And finally, the next slide. We repeated this UEFI BIOS firmware. We think it's a mouthful, and we would love to have a better term, which is inclusive, representative, and less of a mouthful if someone has a brilliant idea. Next slide. Along the way, we have come across and defined the concept of a composite device. A composite device contains a lead attester, which is the term that we settled on in the end. And the lead attester is the environment which has a connection to the verifier, and is going to accept evidence from other attesters, B and C, which could be, for instance, line cards in a chassis. They could be, you might have an aggregate of essentially identical systems, but one of which is elected as the master. So similar chassis concept, but maybe in separate physical boxes. The example of a smartphone where there's a main CPU and a broadband CPU, which doesn't have internet connectivity and therefore doesn't do the attesting. And other devices where there's some devices attached to a system bus of some kind that where not all devices have external connectivity. In particular, one thing I'll note, and we spent a long time talking about, it's entirely possible that attester B or C provides its evidence to lead attester A, who then goes to verifier B and takes an attestation results back, acts as the relying party, and provides that as part of its evidence to its verifier A. And while we have some text that explains a little bit of that, and it's a third dimension to this diagram, that doesn't really change the architecture in any way. It just changes the nature of exactly what is evidence, and that's fine. What matters in this context is that we may have to deal with the fact that we have evidence of composite devices, and this evidence may be signed in different ways by different things, by different testers, and that's the critical part about the thing. Next slide. So you've heard about the topology models. We talked about them way back in the first IETF. We came up with this concept of passport and background models, background check model. Someone does animation. I would sure love to have an animation where the top diagram mutates into the left diagram or the right diagram. That would be very pretty and very instructive. The important thing is that logically the evidence always goes from the attester to the verifier. And you can see on the bottom left, that is the case. It goes directly from there. But the attestation results comes back through the attester and then goes to relying party. That attester, while he could audit or possibly even look at them, that results essentially is not contributing to them in any significant way. It passes them on through a different another conveyance. Similarly, in the background check model, the attester passes as evidence to the relying party, which more or less passes it directly to the verifier without changing it. We have discussions about whether there could be additional signatures or other session layer conveyance issues between the relying party and the verifier, and that's entirely possible. But fundamentally, there's a signed artifact that goes from the attester to the verifier, and that's the thing called evidence. In the background check model, of course, the attestation results come back directly, and people have described also degenerate cases where the verifier is part of the relying party, in which case there's no conveyance, no protocol, it's all internal. But from a role point of view, we see the three pieces and three colors for colorblind people. Next slide. So a critical part of what we're doing here is to get interoperability between different devices, and ultimately interoperability requires that the format of the evidence and the format of the attestation results is understood. And in general, we believe that attesters, particularly constraint ones, will produce a single format of of evidence, or a single device will running a particular firmware will produce a single evidence, and that the verifier will have to accept some set of evidence from devices that are compatible with it. And we're not saying which type of evidence is required, although there is a strong feeling that CWT and JWT should be used for anybody who doesn't have some legacy or other format that they have to be compatible with. Similarly, the relying party is probably going to accept only a single kind of evidence, and it's quite likely the relying party is going to determine what format that is, and the verifier will have to adapt to it. Now, of course, this is subject to many things, and we had a lot of conversation as to whether or not the evidence, there's any negotiation of what kind of evidence is used. And I think we have agreement that, yes, it's entirely possible that conveyance protocols could negotiate what kind of attestation results or even what kind of evidence will be communicated, but that specification of such a negotiation protocol or agreement protocol is not within the scope of the architecture to do, and it would be strictly within the use case or protocol of applicability to do such a thing. That in most cases it's going to be the protocol document which specifies what the format of the formats are, and that this is entirely appropriate. We expect that there will be verifiers that can deal with multiple relying parties, providing some commonality, and therefore may have to speak with different kinds of evidence, different formats. And they will likely speak to a variety of different kinds of attesters, different products, different kinds of products, different revisions of those products. They may move from X509 in an old version or some TPM TCG based thing to CWT in a future version. And so even though the model may not change, the firmware could change, and the verifier therefore may be accepting evidence in multiple different kinds of formats. But in general, the thing to emphasize is that the evidence of a particular flow for a particular device is in one format, and the attestation results come out in one format. There's no requirement that the results be produced in multiple formats at the same time. Next slide, please. That's really it.
Questions?
Our next meeting, I think, will be next Tuesday, unless someone's shouted to cancel it.
I think, and Michael's
we have canceled it because it would be opposite the TEEP meeting. Not next Tuesday, the one after. Well, I'll give you back 5 minutes. Thank you.
Just FYI, my chat is broken, but let me just remind everybody, there is a Jabber room running. And for those who are attending and might have joined late, please add yourselves in as the virtual blue sheets in the Etherpad. Okay, so next up, Lawrence on the claims characteristics.
Hello. So next slide, please. So there's the PR out there. I think we've discussed this briefly, Singapore or elsewhere, but going back about a year, maybe even longer, there was a lot of discussion about how the different claims should be formatted or created or reused, or a lot of people had a lot of opinions about that. So I put together some text that I think described, some guidelines for creating claims. So there's 4 of them here. They should be designed for interoperability. So, one relying party can understand what they mean, so that's a difficult goal because a lot of times people want to do proprietary claims. But there's value in getting a claim design that can be understood by multiple relying parties. There's trying to be neutral for the OS or the technology. So, it's not about a particular operating system. It's not particularly about TEEs or TPMs or JavaScript or mobile phones, or so trying to be neutral about, in that way. Trying also to be neutral about security levels. So we're not just focused on high security environments like TPMs and secure elements. We also consider low security environments like user mode apps. And another characteristic then was want to try to reuse extant data formats, and not reinventing things. So, for example, we try to reuse the format for GPS from another working group. And then I think go to the next slide, please. And there was one more. Yeah, so proprietary claims are okay. And then this whole notion of profiles, separate documents that say which claims are used in which use cases, maybe prohibit some others, maybe narrow the definition of existing claims, all that. So trying to manage interoperability of claims. So the real question here and is, where does this text go? And how does it kind of fit into fit into everything? So we've proposed so this text, a lot of it could be guidelines for IANA, or when new claims are created. That kind of begs the question: is do they apply to CWT and GWT? So, kind of, it's more of I think the question here is not so much about agreement or disagreement about these characteristics. At least so far, there hasn't been too many objections to or just much discussion about these characteristics. The discussion is where do they go? So one, I've proposed putting them in the EAT document. At first, they were just generic parts of the EAT document. Now, I think they might be IANA guidance. But since we're sharing the registry with CWT, it seems like these should be applied to CWT in general. And to me, most of these things would make sense for CWT, not as requirements, but as guidelines.
Lawrence, can you take a question?
Sure. Yeah, that is good.
Dave Thaler?
Yeah.
Okay, my comment is on the previous slide. Actually have so on your letter question, I think IANA considerations of the EAT document for anything that is RET specific is great, and anything that is not RET specific is more for the CWT. That's to answer your question. But the reason I got in the queue was to say that I think there's another characteristic that would be good to add to the list, and I'm not sure how to label it. So let me just describe what I mean by it. It has to do with it occurred to me when you talked about don't reinvent use existing structures and stuff. But it's also important to talk about when inventing claims to say, is it okay to reuse an existing claim, or do I actually need to have a new claim for my own purpose? And so this might be, this entails one piece of that has to do with the fact that you can get a name, such as if you're doing a proprietary extension, you can get a new name or something. That's the how do I generate the ID question. But the other part of it is, when is it appropriate to say, can I have a claim that can appear multiple times with the same name in the same claim set? Or do I need to have different values for it? Or if I had different values for it, would I instead put a list of things inside the claim as opposed to having multiple occurrences of the claim? And so I think there needs to be something around claim design as to how do I design things that are multi-valued.
Can you give an example?
And one other piece of that before I give an example is also what happens if you have some proprietary things and some standards things, you know, don't mix the streams, you put those in separate claims or whatever. So let's say one example is in TEEP, we have a use case that says I need to pass in the claims the set of TAs that are installed, the set of applications that are installed. And elsewhere, I need to pass a set of applications that are requested to be installed but are not currently installed. Okay, and so in each of those two cases, there's a list, right? And so a naive claim constructor would say, oh, well, if I have 3 applications that are installed, do I put those in 3 occurrences of the same claim in the same claim set? Or do I have a claim set that has applications installed and inside it has a list inside that one claim? The other part of that is, let's say I have the list of applications installed and a list of applications that are meant to be installed or requested to be installed but not currently installed. If I put those into the same claims, or those 2 different claims, because those are 2 semantic meanings, right? And so here I might say, as an example of a guidance to say, you know, don't mix those 2, keep those 2 separate, but have the claim have a list rather than having claims have multiple occurrences. But the real point is the design consideration should bring this up and have some recommendations, regardless of whether you agree with my intuition or not.
Yeah, okay.
This is Hank. May I add directly to that?
Roman's next in the queue.
Oh, sorry.
I just wanted to return back to the question you had, Lawrence, about where do you put this text? I mean, some ideas is that if we're sharing the same registries with CWT, we can't say anything that is more permissive than what's in there, because that'll create conflicts. And it occurs to me that the place, if we want to talk about how claims should manifest in the RATS architecture, irrespective of how they're registered in the CWT, it seems like that should be covered in a profile document.
So just to clarify, Roman, by profile document, you mean a separate document from the EAT draft?
And so I guess in my head, let me kind of think through this. I mean, the EAT draft enumerates what the claims would be. I saw in the slide after this one that we're displaying, we were talking about profiles. It would seem that at some point we might want to talk about how they may manifest themselves in kind of the real world and kind of in the RATS architecture. I don't mean to presuppose where it goes. Maybe it's an appendix in the EAT draft. That would be weird, but it wouldn't surprise me if we ultimately published profiles that talk about specific collections of things in the CWT registry, and we can make some statements there.
So I'm a little confused about your comment, Roman, because I mean, my thought would have, one of the proposals was actually a revision of CWT, say, revising the guidelines for IANA for CWTs, because a lot of these characteristics, probably most of them, apply just fine to CWT. They're not really RATS specific.
Okay, I mean I wouldn't have any disagreement with that option too. I mean, to me, that's consistent with us saying, since we share the registry with CWT, we need to at least kind of share some behavior. Then, and we can't be, we can't be, I guess, more permissive. Then that's all.
So Hank and then Jim are in the queue.
Hi, this is Hank. Sorry for my breaking ticket before. I think if you're using CDDL and CWT in general, we are stuck with keys being unique, and therefore we would. I think there's no decision because it's clear that we have multi-value here now, and I think that's fine because semantically it's easier to process, I assume. Also, with specific to characteristics, I think that's a very meta topic here is how do we differentiate attestation results and evidence sets, even in subclaim sets, from standard CWT? I think at the moment we cannot. if you assume that they are reusable in CWT or defined statement in EAT. So I have no hard understanding, is this a common purpose CWT or is this actually really evidence? And you have to guess, as I assume at the moment. So maybe we have to fix that. This is a comment.
Yeah, I think we might have to.
Yeah. So that's basically it.
Jim?
Okay, two things. One, I actually read the set of guidelines, and as a CWT person, I did not think that they were necessarily appropriate for CWTs. I think that CWTs have very, very different guidelines that they should have. The second thing is I will say something that I said eons ago at a IETF meeting, and may have been, but not, I don't think I actually said it up in the room. My recommendation on how you register these claims is you register a RATS claim in the CWT registry, and then you go to town on your own sub-registry with all the stuff you want to do, because you can keep things, you can register things according to your own importance and not according to the importance of the CWT designated experts in that case. And it will also be obvious whether this is a RATS CWT or not in a lot of respects, because if you have the RATS sub map in your CWT claims, then it's a RATS register, or it's a RATS assertion claim.
Okay, no more questions in the queue.
I'm not sure how to proceed at this point. Maybe it seems like ACE working group is not interested in picking this up. I guess or having modifications to CWT, at least based on Jim's comment.
I heard the guidance from Jim as to creating our own RATS registry, if you will, for these claims. And then from Roman, I heard that for the proprietary ones or for the flow that we could, he was suggesting that we have separate documents, and I may be stating that more strongly, to describe them as profiles.
Yeah, I mean, I think that's a conversation we should have. Yeah, I'm not suggesting we need those profiles. It's separating, registering the claims and describing the claims to me is different than describing what set of claims are required for a particular profile or use case, the way we're talking in Jabber.
Hank is in the queue.
Yeah, sorry. About and this is addressed to Jim and the group, of course, where to register and registry. We talked a lot about having our separate registry, and then we would have a semantic impedance mismatch because we would define the same claims in two registries, and we don't want to do that. That was a very fundamental decision I think we made, and maybe Jim has some additional feedback about that, because we were reusing all the good stuff that is already there without creating semantically, well, slightly different things with the same keys, but a different tag at the map, and I don't know. So the idea was to deliberately use the CWT registry, and I think Carsten Baumann highlighted that we could maybe add a row to this, sorry, a column to this list, and indicate what types here are for attestation, remote attestation purposes.
No one else is in the queue.
Yeah, I would agree that it seems awkward to have two separate registries here. And then, like, is it illegal to use a claim from one registry and another if it's a CWT, then you use a RAT's claim, is that like, forbidden and vice versa?
I I think as long as they're orthogonal, doesn't I don't think you run into any issues. The only time you'd have a problem is if one namespace tries to redefine the another something that's in the other namespace. Otherwise, it just gives the developer some guidance in terms of what the semantics are for a given claim.
I guess I'd like various comments, for or against separate registries. Or is it a sub-registry?
Let me be clear. I am advertising a sub-registry. I am not advertising that you create a second CWT registry. I am saying that you're going to create a CWT claim which says this is RATS information. That is a sub-registry which is its own map. And you can go to town in that registry with whatever you want. They are separate namespaces, and they are easily identifiable as separate namespaces.
And it would.
You can use any of the CWT namespace entries, such as issuer, expiration time, that you want.
And they would share a registry or not?
The RATS claims section would be a sub-registry. There would be a RATS claims registry entry in the CWT registry. Therefore, the namespaces are separate. They are separate registries.
I mean, it would, okay. So they would be, it would really be a separate registry for IANA.
Yes.
Okay.
This is Dave Thaler. Question for Jim. I'm trying to understand your proposal. If you have a RATS claim with, if I understand right, are you saying that there would be inside of a RATS map, there would be claims inside there separate from claims outside of the RATS claims in the same CWT? And if yes, then are you saying that inside the RATS set of claims that you could reuse non-RAT specific values, or those would be outside of that particular map? I'm just trying to understand your proposal, and I'll have a follow-up question based on the answer.
The answer to the first question, I believe, is yes. The answer to the second question is, if you wanted, for example, to use the expiration time element, which comes as a standard CWT registry or CWT claim, you would use that expiration time claim outside. So the CWT claims would be expiration at tomorrow, RATS map, RATS 1 claim, RATS 2 claim, RATS 3 claim.
Okay, thank you for clarifying. So in other words, what goes inside the RATS claim would only use things from the sub-registry, would not be able to use any of the values from the other registries. You'd never have both values mixed in the same map. Okay, so then I think the challenge, and I'm not saying it's insurmountable, but I think it's a little bit awkward, or at least people have to carefully write code and carefully write rules, is if you have a set of things that are outside and a set of things that are inside, you have to carefully write the correlation rules between things that are inside and things that are outside to know, say, which RAT specific piece goes with which non-RAT specific piece in the claims. And so if they were in the same one, you could do one type of nesting structure. If they're in two separate places, you have to do a different nesting structure. And I'm not saying it's not insurmountable, it's just more complicated than having one nesting structure.
Can you give me an example?
We've talked about cases where you have multiple claim sets inside the same CWT. And some of those are cases where they're nested, where, like in the layered attestation example that Michael showed, you have one that references the second one that references the third one. Inside each claim set, there's both potentially standard ones and REST specific ones. And so trying to just show the nesting relationship between the first set, the second set, and the third set, I'm just saying it's tricky. It's absolutely doable. You just have to do it more carefully.
Don't believe it's any trickier than having it as a flat registry.
So we have Hank, then Thomas, Jono, then Carsten Warman.
Saying Dave make an excellent job in making my point. So I basically think it's more complicated, and we have to burden a lot of other documents with complexity. And yeah, that's it. Thanks.
Thomas, are you in the queue or no? Okay, Karsten.
Yeah, over in Jabber, I just created a simple example of how such a nested CWT could look like. And I just copied that over to Webex chat. And basically, fundamentally, there is no difference between having this nested namespace and putting it into the top level CWT using some other namespace mechanism. You have to define the interactions between these claims in all cases. So I don't think that actually nesting the thing is creating additional problems. But we are still stuck with the original problem, which is we have to define all the interactions between claims that we think are interacting. So if my ClassRAM 2 there in the example has some interaction with NBF, we will have to define that interaction independent on whether it's represented as a nested structure or represented as a CWT claim at the same level as NBF.
Okay, Lawrence.
I guess thanks for the comments. I'll guess I'll think about it and make a proposal. Or maybe two proposals to choose between. I'm not sure which way to go yet.
Yeah, I mean, it sounds like you should just try them, given the guidance and suggestions you've been given, and pose your results, or maybe you'll come out with one or two, a good proposal, or maybe two.
Yeah.
All right. Thank you for that. Okay, next step. Have this out of order. I think next step was the timing definitions. Eric. I have.
All right, can you hear me?
Yeah, I'm trying to find. There we go.
All right, I'm going to be talking about some of the events that we've been talking about in the architecture meetings. I want to give thanks to Dave and to Lawrence for doing some help in scrubbing them, as well as Wei, who talked about some of the architecture diagrams and the flow diagrams and some of the early threads. The basic concept of what we're trying to do here really builds off of the use cases. We have use cases that are built out in the use case document, but we need ways of relating the use cases together. What makes them common? And the goal is to define event definitions which span these different use cases. And if we're able to define these event definitions, the hope is that by including the definitions in the architecture document, we have a language which can help us more formally frame characteristics between the use cases, such as when do you send a nonce, or when do you drive and create results. And with that, we can build call flows or timing diagrams, whatever you want to call them, which expose the similarities that we all know exist between the various use cases that are in the use case document. So in this meeting, in my session, what I'm going to do is two things. I'm going to go through the 9 event types, which a number of us have seen as reusable across different use cases. As I review those, get your feedback on those 9. And I'm going to have an ask for you either on the call or in a subsequent email to say whether you have changes that you'd like to make to those 9 definitions. Beyond that, there is the possibility there are other common event definitions which we have not exposed yet. In some dialogues and in some other drafts, I've seen the hints that there might be some other timing events which could be common across the architecture, but it'll be up to the members of this group to go ahead and do what it takes to assert that you have an event which you believe is common enough to go ahead and include in the overall set in the architecture document. Now, if it doesn't make the architecture document, that's fine, because you can always define them in your specific use case documents or your specific technology documents. But if you really want them to be considered as reusable events, the best place for them, of course, is the architecture document. So 2 asks: review the definitions, and 2, see if you have additional asks. I did just send out an email that is pretty much summarizes everything I just said and provides the event definitions to the alias. So if you're unable to expose the information right now that you want to, the best place is to do that on the alias using the thread that I just started. All right, next slide. So what are the 9 event types which are contained in the current architecture pull request, which Dave Thaler has posted? You can see a number of different things, from the value generation when a claim was created, to when you'd send a nonce, to everything to when you generate evidence, and others. I mean, we could review these one by one on the call, but again, the ultimate arbiter of rightness is going to be the document. So rather than read any of these, and since many of these were actually on the alias previously in earlier threads, perhaps there are people who have questions now on any of these 9. I'll just leave it out there to see if anybody has any initial questions on some of these potential claims. And I see one from Dave.
I just wanted to clarify one statement that you made. There's actually 10 in the pull request. The 10th one is not on this table, obviously, and the justification for the 10th one is in the document. However, the caveat is that the 10th one, depending on the protocol, it might not actually be in a claim, and so it's certainly an event type. That's the attestation results relayed, and so it doesn't list that in the pull request as being in a claim, because it could be passed in the transport protocol, or it could be in a claim depending on how you define the protocol. So that might be why it might not be the 9 that might appear in the EAT document, for example, or it claims it would be usable in EAT, for example, but it's certainly an event type that there's a security check that needs to be done that's explaining that pull request.
All right, I think that's a good one for the alias. Initially, I think we had talked about evidence relayed and whether that was enough, but we can certainly go on the alias and discuss that one some more, whether it's the same, whether it's different. Again, we do have to do some, I don't call it genericization of these, because some events are going to repeat, but apologize for hitting the 9 instead of 10. If I missed it, then I just missed it from earlier threads.
Hank is in the queue.
Again, Dave beat me to it. Dang it. So yeah, I have nothing to add here except the comment that I think this should be at least informative guidance in the architecture to have consistent different references. Yeah.
All right, makes sense. Again, it'll be up to you guys to determine whether the definitions are right. And I expect a question from Hank in a couple slides. But these are not all the possible timings. We're really just trying to nail down the commonly used timings, or the most commonly used timings. All right, next slide. As you're going to see in this slide and the next one, as well as what Lawrence is going to do in a few minutes, there are people who have taken the timings, the event timings, and placed them into a into a flow diagram, which allows you to see how events would play out for various drafts. This particular flow matches to draft Fedorko, which is doing a remote integrity verification solution. And what this includes is the idea that we have on the top left the creation of a claim, effectively in placing the claim, in this case, into a TPM, where it's generated within the TPM actually by other values being inserted into the TPM. A random number coming from a relying party, which drives the generation of evidence, which is then pushed to the relying party, which then can go ahead and verify that evidence in order for the result to be generated and returned back down to the attestation result received, where it is then appraised by the relying party. So this is an example flow. And of course, the relying party then will only have to have the values acceptable for a certain amount of time. This is the way the information is supposed to be used. And I do expect to work with Guy and have text that shows this as an appendix in his excellent document in order to show, again, a way to allow this use case and the timings between them to be correlated between different drafts. Next slide. All right, what this slide does is it shows something I'm going to talk a little bit later in the session when I get to my individual draft. This is the generation of composite evidence within the attester. In this flow, we have, again, the same way we started the last flow, the generation of a claim within a TPM and the extraction of the set of claims from the TPM with evidence generation and evidence one being passed up to a verifier. At that point, we go ahead and send attestation results back down to the attester, but then we start another attestation process. Verifier B has a new nonce, and that nonce is identified with NS prime, and that's how we're thinking we should identify the reuse of event types in a diagram. You pass event 2 across, and then various composite elements within the attester take the original attestation result and mobile evidence from EG and EG prime to send the result over to the verifier, and the verifier B then looks at that information and will do its own assessment of the evidence, appraisal of the evidence, in order to take a result and then allow the result to expire. So this is at least one proof point that many of the event times that we were just talking about are event times which, again, are common across different use cases. Lawrence will have more in a second, and I see a question from Dave.
Yeah, my question is actually on the previous slide.
All right, we can jump back.
Okay. So here I was just comparing this diagram to the one that's currently in the pull request, and I had an observation on this diagram that I think there's a couple things that are either missing from this, or perhaps you need something other than the non-space background check. And so in particular, if you look at the bottom half, you see time RX is on the bottom. Back in the table, RX was defined by the verifier. And so unless you have synchronized clocks, that time RX is not known by the relying party in any comparable way. And so you need nonce checks over there between the relying party and the verifier that's not shown here, although this is only showing the nonce check between the attester and the relying party. So what that means is that this diagram is not showing how the relying party knows that the attestation results are no longer fresh. You need more than what's on the slide in order to determine that.
Agreed. Basically, the question for any diagram is how much do you expose in the diagram and how much do you expose in the underlying text with the diagram. And at least for this version, I was trying to simplify the event times rather than talk about the deriving and the carriage of some of those times within the other elements. So the diagram is a tool. The definitions are eventually going to be have to be included in a combination of the diagrams and the document itself.
So if people want to see a longer example, they can look in the pull request, which does have a non-space background check that has more than what's on here. It has other extra stuff on the bottom right side with the explanation of it. And so if people want to see that, feel free to compare, point out if they find any issues in the pull request, let me know.
Yeah, absolutely. And one of the fun things that this does is if you go back to the very first thread that we put together on this, there are a lot of discussions on how many nonces are sent, when are they sent, are they shown or not shown. The tool of these diagrams is quite effective in exposing things which people take for granted. For example, some people want a separate verifier to send a separate nonce to the relying party in order to gather the evidence. Is that required? Well, maybe not if the verifier is able to look at the attestation results and they don't care that the verifier doesn't have to care. They don't care if the verifier's assessment went when it happened. So these kind of diagrams show the variance in the types of processes which people are using, all of which are valid based on which entity that you might own. And so these are again, showing that there is a language constructed which allows us to make a lot deeper comparisons between what we're doing from our use cases that would have been otherwise apparent. All right, back to the next slide. And a question for Hank.
Thanks, in the queue.
Yeah, so this is because at the end there's always this attestation results no longer fresh. So we're talking about freshness here, apparently because nonces also. And I think that is an extra reference frame here for talking about freshness versus recentness, which we are planning to add to the architecture, I think. And so this would be another good reason, because this types of points in time are basically relevant for the freshness, recentness discussion. I think Dave can add to that.
Go ahead, Dave.
Yeah, the section 9 on freshness in the document already does contain a brief discussion of the difference between recency and freshness, although I don't remember if it uses those terms, but the concept it completely explains, but it doesn't go through the examples. And so that's what we're talking about adding, is the examples. And for everybody else that hasn't looked at the pull request necessarily, all the examples and stuff will be in an appendix that's then referred to from the freshness section. Because it just adds in learning and has references to things that might be used in, each or whatever else. And so, but the short version is in there in like a 2-paragraph form.
Again, so we have a toolkit. This is a toolkit which is only as good as our definitions of times and the way we decide to construct the diagrams. So any other questions before I jump to the last point on the overall structure and purpose of both the event times and the way to expose them in the sequence diagrams?
Eric, you're actually over time, but I'll give you a couple more minutes.
This should just take a second for the last slide.
Next slide.
Last slide. I wanted to highlight in purple that there are other event types which I've heard in discussions. One that came from Tuda is, do we want to have a centralized nonce or handle distribution across multiple devices, where it's a possibility? So the last ask I have for you is, if you have other times that you want to include in the architecture document, now is the time to propose them. I don't have a need for these times, but others do, and I didn't want to hide the potential times which I've heard in previous discussions. So this is just a kind of like a mind reminder to say, you want this time? If so, you're going to have to argue with them. And that's it. That's it for me.
All right. I can give time if there's one question, but I don't see anybody in the queue. So we can switch over and continue on the timing. Lawrence, you're up next.
Yep. Okay. Next slide. So what I'm doing here is taking, that's the old slides. I sent a revision.
You did?
Uh-huh.
When?
Yesterday, probably around noon. Because after I saw Eric's new diagrams, I redid the presentation in a substantial way.
Claims characteristics.
It was sent before that.
Okay, my bad. In the interest of
Project your
time,
own.
what's that?
Maybe he
Is
can
this
There we go.
project his own.
There we go.
I'll upload these while you're talking.
Okay, thanks. Sorry about the confusion. So I looked at Eric's diagrams and tried to think about how the different time events would fit into EAT, and whether they fit and how they fit. You know, whether EAT was covering all of those things, just to understand if EAT was complete in this way to be able to handle all this. And the answer is maybe not. It needed some work. So I'm going to go through about four or five slides here talking about each of these different times and how they should manifest in EAT. First as in evidence, and then secondly as in attestation results. So this first time VG, or value generation, I believe that was time A in the old diagram. So there's the idea that a data item might be generated at some time long before attestation is, in the picture, long before a nonce was received, maybe even outside of the attestation, outside of the attester. And so that data might be long precede the attestation. So the example here I'm giving here is a GPS position location acquirement that happens in the GPS subsystem. Maybe the GPS subsystem is monitoring position, and then you go into a basement and you don't get GPS anymore. And the GPS subsystem is recording the times at which it last knew a good location. So that's all done outside of attestation. So now this comes into into the attester. You're generating a claim. How do you deal with that? So one approach could be that every possible claim that we can define can have a timestamp associated with it. I'm saying I don't think we should do that because I don't think most claims are of this nature. Many claims are, but not most. So the proposal here is that each claim that has the possibility of being cached or generated at a time before the token is being created, before the evidence is being created, should have fields or data items as part of it to indicate when it was generated. So individual claims have to be modified. So I'm giving an example here for the location claim where I have a timestamp, which is an absolute time, and an age, which is just the number of seconds on how old it is. And you use one or the other, but not both.
Can you take a question?
Sure.
So this is Steven. So I have a question here that I don't know the answer to, and this actually harkens back to that discussion we were having about guidance for people defining new claims, because we probably want some guidance in there too. And the question is, do we think that it will always be the case that somebody defining a new claim will know whether a timestamp would make sense for it or not? Is that because it seems to me that there's an assumption in your proposal that that's already known, and maybe that's true. I can't tell whether I haven't decided whether I think it's true or not. So I'm asking, do you think it's true that you'll always know when creating a claim whether it needs a timestamp or not? Otherwise, if for some reason no, that means you either need to define things twice, which I don't like, or you'd have to have a way of having a more generic mechanism, like having some wrapper where you can have the claim and other metadata claims about it inside the same map, for example.
Yeah, good question. Do they know? I was kind of assuming they probably would. And I'm also was trying to help maybe avoid some complexity in that, in trying to come up with some sort of a general mechanism to be able to timestamp any claim.
So this is Ned. One of the ways to think about this is that policies can decide or determine what the requirements for whether or not a timing or timestamp is needed. The challenge is coordinating the policy requirement with the attester who's doing the collection to know that they're trying to meet that policy. And I don't think that's a topic that's been discussed.
I mean, you have to have data structures or data items to to be able to have policy. So I just was trying to think about the data items first, and then sure, lots of policy can do lots of stuff with different things. But and as you can see from the CDDL there, the timestamp and the age are optional. So policy could reject if you're if it's missing. But just the question is, can you do we try for some sort of a general
I think my point is that there's potentially two entities at play here. One is the policy owner who's setting requirements for what they expect, and then there's the attester, the implementer of the attester, who's trying to satisfy that policy. And unless there is some mechanism for coordinating those requirements, maybe it's captured in a protocol somewhere, or maybe it's captured in a requirements document somewhere. Or maybe it's just tribal knowledge. Somehow that those two entities have to agree on what the requirements are and how to satisfy them.
Okay. So, I mean, I think Dave's question about the do they know that's probably a really key question. I went through the claims that are defined in EAT today, and seemed like most of them it was clear, and most of them were pretty clear that you would pick them up right away. There wouldn't be any caching or older values for them. So that's one of the reasons I went this way. I think it would be good for everybody to think about this. Maybe I'll post an email to ask for if they would know. The other claim that we haven't got in yet is anything to do with measurement. Clearly, measurement would matter, especially with something like runtime integrity check. That really the age of that or the timestamp of that really matters.
Dave Taylor has a follow-up question.
Yeah, I'm thinking that timestamp was not the only type of claim about a claim, claim about another claim we have. I mean, we had discussions, I don't remember what it's called, but I'm sure you remember that the notion of, how is it connected? Is it, on chip or on bus or something else? Is a claim about a claim or whatever? And so what it's in the Jabber chat room, I put an example of a way that we could do it if we do it generically. And again, I haven't decided yet whether we need to or not, but I think it's doable and it's extensible. And I suspect we will find other reasons why we might want to do something like that too, where you define a claim that's a map of other claims that contains one claim and then the set of metadata about that claim. So I just point people at the Jabber room if they want that idea. Again, I don't know if it's something we have to do, but I think that as we go through other types of claims about claims, I think timestamp was just one of an example of multiple.
Okay. Next slide, please. So some devices have clocks, and some devices have don't, and some devices have clocks and their clocks are unset sometimes. So to deal with that, the idea is to have two different ways to represent here. One is a timestamp that just, standard CBORD tag 1 epoch time. That's preferred. If your clock is set, use that, and that's all good. If your clock is not set, it seems that there's value in an age claim. To be able to do an age claim, you have to have a ticker, something that measures elapsed time. So like uptime ticker, like Linux works. Then it's up to the verifier to kind of take a look at it, and the verifier has these 2 times e.g. VG. I think I got that wrong. I think that should be nonce generation. Oh no, I'm sorry. It's the elapsed time. So the age is the elapsed time between the value generation and the token generation, e.g. And then the verifier can compute that, get to an absolute time by pinning it in between the nonce generation time and the receipt time. I believe it makes no sense to have a, that's actually next slide, but so anyway, the timestamp and the age, that was the idea between the timestamp and the age. There was an age claim in EAT. I removed it because that was really more of a claim about a claim. It was just sitting there as a top level claim, but I think Dave's characteristic is as a claim about a claim. I think that's so. Any comments about age versus timestamp?
So I just inserted myself into the queue into the WebEx. The timestamp is clear. What I'm undecided about is whether an age claim by itself is, or meta claim, if you will, or like timestamp, a claim about another claim, whether that by itself is the right way to express things. That's certainly one possibility. Another possibility is where you only have, say, deltas between particular events. So I'm just going to make something up because I can't pick something on the slide here that's relevant. So let's just pretend that the time EG minus VG was interesting on the left here on the tester. I think it was in one of the other diagrams, but not on the one that's on the screen. And so let's say the evidence needed to include, maybe it is in this one, the evidence needed to include needed to include information that let the relying party determine time EG minus time VG. Right. One way to encode that would be to have 2 different claims, one that is age VG and one that is age of EG, and have the relying party do the subtraction. Okay. Another way to do it is to have one claim that's just the delta that the attester puts in. Okay. Between those 2 approaches, the second one is obviously more compact because there's only one claim instead of 2. What I'm undecided about is whether there's enough use cases for having age of VG and age of EG be appearing in there twice. That might be possible, and that would align with the example that we talked about with timestamp, where you had a collection of metadata about each claim. And so I can see advantages of both of those, but I don't know which one is better, which is the question that you're asking.
Yeah. So let me do 2 more slides and then get to Hank and you come in on what you have to say, because I think this slide and the next will have some use for it. But don't go next yet. I just want to. So on this here on the nonce, in Eric's timing diagram, the time of the nonce is noted, but I don't think there's any reason to put it in the attestation evidence or the attestation results. So there's no field for recording the time of the nonce, and I think a couple other times are of that character. Okay, go to the next slide. Time EG, that's the time of token creation or evidence creation. The proposal is to use the issued at time from CWT. It seems like it fits correctly there. This is the time all the claims are formatted and the signature is applied. I didn't see any reason to be more fine-grained than that, like say, well, this is the time we collected this claim, and this is the time we signed it, and this is the time we sent it. It just seemed like it's all kind of happens pretty quickly, and there wouldn't be any reason to be more fine-grained than that. So there's just the one time issued at, just like a CWT and a JWT have. This time is always an absolute time. It's never an age. And basically, if the device has no clock or the clock is unset, then you just leave this claim off, and the verifier has to go by the constraint of it's either it's after NS and before ER. Okay, so now Hank, go for your question, and Dave maybe then answer some comments from what you were saying.
Hi, Hank. With respect to TUDA, the unidirectional time-based stuff, so it's not using the nonce conveyance method, or one of them. Ties relative time always cryptographically to absolute time that is trusted, to mitigating that step. So in TUDA, for example, this age semantic is not captured in evidence, but in a separate protocol-specific channel, which is the synchronization message, which guarantees a trusted closeness of the relative to absolute time association. And that is therefore not a claim per se, but a protocol header item, you could say. It always depends on how you work this. So defining the claim in itself, I think, is useful. Age is a little bit, well, it's 3 letters, that's nice, but it's a little bit generic. So you have to really always have to read the text. It's not so intuitive like issue that, you know. So maybe there's a better name for that, but that's tiny nits. I think in general, this is a good way to approach this. But I wanted to highlight it's not necessarily a claim.
So in TUDA, you always have a clock that's set, right?
We have 2 clocks, the relative clock and the real-time clock on the system. And then we have a external source that you can reference, you can get a token from. That is a handshake. And then have a trusted reference for time. And this, unfortunately, clocks are not very accurate. The accuracy of clocks varies. So they have jitter, and they are drifting. And therefore, you have to resync and set new points of time where you start this trust relationship of synchronization again. Actually, it's 3 clocks, if you talk about the external clock also.
Okay, I was going to say that in TUDA, you would always know what time it is. So you would never use the age claim. You would all use the timestamp claim for a VG.
Yeah, but the relative time is a tick. You have no idea when this tick is. You have to couple it to real time. Without real time, the tick is not meaningless to the outside world.
I'm not sure I'm following that, but I mean, to me, it's the verifier and the relying party that really want to know when the value was generated in an absolute sense. So trying to get to that.
And in TUDA, you create evidence, but it only includes ticks. So you have to couple it to a trusted real world time in order to make the relative useful in the global scale. And I thought you were talking about ticks somewhere and said that age is ticks and therefore relative. So that's why I was picking up on that.
Yeah, but the idea is that somehow to take the tick count in the age and turn it into an absolute time, because that's what the verifier and the relying party are after in the end.
Yeah, just highlighting it is not easy to have that done in a trustworthy manner without an external trusted time source. Your real-time clock is not a secure source of time, and GPS can be spoofed and such.
Okay. All right. Well, I'll look at the TUDA stuff and see how I think it fits in, but I guess you're not really proposing any change here. Dave, did this answer some of your questions, or do you have some comment on this?
Have any further comment? I haven't changed what my original question was. So I am still wondering. I mean, right now I'd be inclined to say, sure, go ahead and define an age claim in a, but I don't know if there's a strict need for it, but I don't have any objection to adding it. As I mentioned before that on the last point about should you have the ability to group metadata about claims, I said timestamp was just the first one of a set, and it could be that age is another one, and how strong you apply your trust in the actual value itself might be a third one, and so on. So
Okay.
I'm fine going on. I haven't changed what my question is or where my head is at, but I guess right now I'm slightly leaning towards having a generic metaclaim mechanism rather than having timestamps or ages or whatever else stuck into the claims itself as the other proposal was.
Okay. I mean, one of the things when I think about those kinds of things, it's just code size and complexity. Typically, relying party and verifiers don't have code size with issues, but sometimes if you're trying to do verification on the device, then that would have some code size implications. Okay, next slide. All right, so results creation. So I'm assuming that attestation results can be in EAT format. The CWT and GWT have a expiration time. They also have a not before time, but I don't know if that's useful here. But they already have an expiration time, so the idea is to use that. Then it seems obvious at first that the issued at claim can be used to record the results generation time. That fits nicely, except begs the question now: how do you carry both the EG time and the RG time in the attestation results? I'm assuming the relying party will want to know that. They can't both be the IET claim because you can't have duplicated claims because of the duplicate keys and maps rules in CBOR. You could redefine the claim to be an array of things, but to achieve that, if you wanted to. So it seems like there's two options that I could think of. One is that you start including the full attestation evidence as a subpart of the attestation result. So that would be an interesting change to EAT to allow that. EAT generally hasn't been, not too much work has been done on EAT for it to carry attestation results. Another would be to define a results issued at claim so that they can coexist. Maybe there's others. But I think this opens an interesting question about formats of attestation results. I didn't have anything other than these two proposals that don't have an answer yet. I might lean towards A here, putting all of the attestation evidence in the attestation result, because verifiers and relying parties, especially with big data and machine learning and all that, they live off of data, so the more data, the better. So comments or questions on that? Dave?
So this is Dave. I certainly wouldn't want A to be mandatory for, say, TEEP, for example. So I don't think that that's necessarily, I think that would be something that would be up to a particular profile or use case or protocol to define, but I certainly don't think it should be mandatory for all of them. In other words, especially if you have, say, a relying party who's a constrained device, shipping them a whole bunch of evidence that they don't want doesn't actually help the constrained device. So that's why I would argue against A for being a inherent part, although I have no problem with A in a particular profile, for example, if somebody wants to do that. The other question I was going to ask is, you said that you thought that the relying party might want to know time EG, and I am not sure I understand why that is. I could perhaps understand if a particular claim in there is passed from the evidence and copied back in the attestation result, that they might want to know time VG, the time that value was generated. But when that particular value was composed into some larger set, I don't know why the relying party would care. And so that the onus would be on the person proposing that to say, why would the relying party ever care about time EG inside of an attestation result? I could certainly buy the time VG in the attestation result, but EG, I don't get that.
Okay. I mean, EG is, in a way, it's the VG for all the things that were not cached in any form. But yeah, good to think about.
But it's really whether the values appear in the attestation result. And certainly there should be many cases, use cases for which the attestation result is lean and mean. You know, the verifier vouches that the evidence looked good. The end. You just trust the verifier. If you're a tiny constrained device, that may be exactly what you want because you don't have the code size to do any other checks. Then does it come with a verifier that I trust, right? And so keeping that to be small is great. Having other complexities in there, if a profile wants it, just don't make it be mandatory.
Yeah. Okay. Okay, that was all the slides I had. I don't know if there's any comments or any more comments or questions, but thank you.
All right, up next is back to Eric.
Hello. Now, initially the slides I put together were for the interim. That's why it shows RET's interim, but it's actually the virtual rather than interim. This is talking about a use case, which is a new one that was introduced at the interim. And the use case is one that depends on things like draft Fedorka and has implications to other drafts like the draft PubSub. So I thought it would be good to give a high-level overview of the draft as well as the current questions that are open. I don't have any asks right now other than consider the context and consider some of the things I'm going to point out about composite evidence, which I'm going to be describing in a few seconds because I know I don't have a lot of time for this. So next slide. Now, there is a use case that's interesting for finance, military, government, medical types of users, where you want to make sure that traffic in a network flows only on devices that are recently attested and their attestation results come back as that they are trusted. The goal here is to have sensitive flows bypass devices which are not currently verified to be secured. There's many types of tests that we could try to attest. It could be as, I don't want to say as basic, but as straightforward as checking the boot integrity of devices. It could become a lot more complex as well. So the basic use case is a trustworthy path through the network. Next slide. There are two ways to do this. We could get attestation through the background check model, much as Draft Fedorka talks about, by having the attestation information passed up to the verifier in something I'm calling an attestation event stream, which I'll chat about more in a second. And with the information being streamed from each of the devices, you can go ahead and push a path to get to the target resource at the either end of the network to make sure you choose a trustworthy path. Next slide. The other option is one that is about composite evidence. In this case, you get your information from the attestation event stream up to the verifier. And at the attestation, in processing the attestation event stream, you then send attestation results back down to the router. When the link comes up, or periodically with protocols like 802.1x or MACsec, you can go ahead and do a new quote from your attester, include that information returned from the verifier, and at each peer device decide if your peer device is currently trustworthy. Details on how to do this are in the draft. If it is currently trustworthy, you then add the links to your peer as part of a layer 3 topology, which again allows you to construct and change dynamically paths through the network for trusted topologies. Next slide. There are 3 major elements that are interesting here. The first one is an attestation event stream, which builds on the Yang model that's already been adopted by the work group, as well as some subscription work over in the NetConf working group. And we take notifications that include evidence and pass them up to the verifier. And this is a link to the Yang models that allow pretty much real-time information be pushed up to an attester and processed. So that's the first main element of the draft. Next slide. Second main element of the draft is something that we haven't talked much about yet in the group, but I think it's going to become a big thing over time. And that is identification of levels of trustworthiness, or even levels of results that are passed down to a device. For example, do we need things that are claims that identify whether the device is compromised, if it's unverified, if it's boot verified? At some point, we're going to have definitions of some results which might or might not be reusable across drafts. And again, I'm not asking for any answers yet on this draft. It's just showing that this discussion is one I expect the working group will pick up at some point. And then the last slide. In the last slide, this really just goes back to the timing diagrams that I showed in my last presentation to show that as part of the timing of the flows, we're going to be passing composite evidence at various times between various devices. And again, this is just showing the importance of composite evidence and the ability to take multiple things at an attester and be able to send them to a relying party and verifier to go ahead and process things. We don't assume necessarily that the verifier is the source of all information. Verifier A is the source of all information which needs to be verified. So this is mostly information for the 3. Any questions?
Yeah, Eric, this is Dave. In this specific case, in the composite evidence, is there, the cases that you're using, is the composite evidence itself need to be signed, or is it really just a collection of individual pieces of evidence that can be put in the same transport?
B.
Each individual piece of evidence is signed.
B.
Okay, so then we don't need any way necessarily to have composite evidence be, inside of the each, right? This is just a set of each that are all passed in the same transport.
Well, it wouldn't necessarily be eats in this case because we have another format with the TPM, but yes, there is
I misspoke, yeah.
There is one thing that is worth highlighting. We have to, if you look at the composite evidence, you're going to see that there is a signature that is included in one bit of evidence to another. One thing that you have to consider is the timing of these things have to be bound together. So you do have some binding between these claims and including information. For example, at step 1, the signature of the information from the attester in the results that are sent back in step 2. So there is a binding where some of the evidence will be included in other signatures to prove provenance and timing.
Okay, thanks.
All right, so that's it for me.
Okay, so you're asking people to review this document, Eric?
Absolutely, review, especially start thinking about where different levels of trustworthiness are being encoded, as well as the importance of composite evidence and the fact that some people have talked about passports or passport models. At this point, this is a combination of a passport model and the background check model, but I was initially using the word passport for what is being sent across. I do think that the word passport has to be used very, very carefully, as I certainly am not willing to have the word passport be used only for unmodified information going between devices.
Okay. So a request has been made to review and comment on the draft,
Please.
and we'll take it up on the list. All right. Next we have Wei.
We have
Yeah.
a question on the queue, Lawrence.
Oh, sorry, I missed that. Lawrence, you had a question. Lawrence, you're on mute.
Thank you. Sorry. Yeah. If you're calling something a passport, it should be signed. It should be stick to the analogy of a real passport, which means it's something that's probably been signed by somebody like a verifier, and that the holder of the passport doesn't modify it. So I think you're moving away from the term passport towards composite evidence that seems in line with that.
For a way to look at another way, when you take your passport to another country, they stamp it with their own effectively
That's true. Yeah.
signed evidence, and therefore it is modified and updated and is a living document.
Oh, okay. All right. So yeah, in that way, yes. But so there's different parts of the passport that have different characteristics.
Exactly.
Yeah. Okay. So now we need a blockchain, right?
Well, hopefully not, but but the ideas are important to see that the passport has to have some living, breathing elements to it, just like a real passport does.
Because that living aspect of it, I don't think that's in the architecture document.
And that's why I'm highlighting it here, is that we have to make, actually the word passport is not used in the architecture document, only the passport model.
Okay.
And that's why I brought it up, is that we just don't want to use the word passport unless the definition allows both stamped and unstamped things.
Okay. Thanks.
It's worth noting that the structure that we would call the passport, which is the attestation results, is included in the composite evidence unchanged. It's just augmented with these other signatures, which I think are the equivalent of the stamping.
Exactly.
I'm wondering if that shouldn't also be captured in the architecture draft, because I didn't see anything to that effect in the latest version.
That's why I brought it up as composite evidence. We had early discussions. I would love to identify, but actually, if we put the word passport in, I think it has to be identified. Right now, the architecture document doesn't include the word passport. It only includes passport model. So I think it should be included. And my only requirement, if it is concluded, is that these models are supported.
I think there may be an open question around how prescriptive the architecture should be, given that the architecture also supports hybrid models, for which complicated to try and give each hybrid a name give it a name.
All right. We obviously need more discussion for that in the architecture too then. Okay, let's move on. Wei Pan?
Yes. Can you hear me?
Yes.
Okay. Yes. I'd like to introduce our not a new, but still I think it's new draft netconf using netconf PubSub models for RATS interaction procedure. We presented it at the last meeting, and we have updated this time, but it's not a big update. So here is I think it's a brief introduction also to our thoughts of this draft, how to go on the further work on this draft. Slide, please. First is a quick recall of the draft. What we want to do, we want to use the netconf PubSub mechanism. In brief, it can be is shown in the picture that the attester receives the verified subscriber to an environment
and the testers will record the happened events and then publish the event record to the verifier. So it's different from the traditional challenge response interaction model. It's it's different, and it's suitable for the use cases where you want to use on-change remote attestation. And when you use it in a larger network, it will be more flexible. And Eric's draft also described to use this mechanism, so I think it's also a suitable use case for routers. And the benefits are obviously inherited from the YARN pub sub and YARN push mechanism, and like flexibility, efficiency, etc. Next slide, please. After some discussion, and we have some key points for our document. First is the scope of this document. We want to define the suitable YARN models for the TPM-based network devices like routers, and based on the draft REST YARN TPM charter, and based on this scope, we will further define detailed models, including the event streams and the subscription, like all this kind of stuff. And we have planned a detailed YARN model, and we are preparing our new update soon. And in the new version, we will describe how to solve the freshness problem. Mostly, we will use the time-based mechanism, such as to the draft, and also use announce and periodical notification to solve the freshness problem. And some of this has already been written in Eric's draft, and we will. That's a good. Next, please.
You have a question from Dave Thaler, I think.
Okay.
Hey, this is Dave. I'm going to ask the same question that we talked about last IETF, but I didn't see the answer in the document yet. And so this is a reminder to cover the stuff in the document, which is in your sequencing diagram. The first line was that the verifier doesn't subscribe with the attester. And the original question was, how does the verifier know when to subscribe, right? The attester may or may not be up at the time. It may be in the middle of rebooting. So how does it decide when and who to subscribe to? I don't think that's covered right now. And I think to tie that to a particular use case or something to say, how would you know? Because that's really, you can't use this until after you've answered that. And so you need to cover that first. The step 0, as I called it in the first email.
In my feelings, I kind of think that's a part of implementation part, but I will consider that, and further I will address that as much as I can, and in the draft, and discuss with you later. And thank you for your question.
Voigt has a question.
Yeah, I have one follow-up to that to consider. One of the things about the YARN subscription drafts is that they depend on transport. If your router reboots or something goes away and comes back, the subscription is recreated. So the underlying transport will solve part of the problem that you're describing, Dave. And then that could be included in the document as well. So look at the transport drafts and some of the replay mechanisms. They do have tools for solving this.
Yeah, Eric, and if I remember right, that particular transport, because like I said, we had this discussion at the hackathon at the last physical IETF, where at least Frank and I don't remember who else was part of that discussion, but I don't think it's in the document. It says when the attester reboots, if it has a cache subscription, then it proactively reaches out to the verifier, as opposed to the verifier reaching out to the attester, and that's not shown in the sequence diagram. But that's what my recollection is from memory. I could be wrong, but it's not in the document right now. So that's all I'm saying is please add that to document.
There's a nice little Easter egg in the RFC 8639, knowing this was going to be coming. When you do subscribe to a device, it will give you the events since reboot that are relevant for that device.
Right, but if the tester doesn't proactively reach out to the verifier on a reboot, right, which is what I think, Eric, you were saying does happen in a transport, right? If it didn't do that, then it couldn't talk to a relying party that relied on, say, a new attestation result until after it waited around for the verifier to reach out to the attester.
Absolutely.
Okay, Wei, I think you
Okay.
can continue. Yep.
Next slide, please. Yeah, it's the last slide, and we will take the draft based on the discussion we had before and define more details. And we will welcome more reviews and comments. And that's all.
Okay, thank you. All right, with that, I think we've completed the agenda. Any other comments or questions? We are, so let me just do a reminder for those. I do see most everybody signed up on the blue sheets, or Tom, thank you for adding them. It would be good for call-in user 4 and call-in user 8 to identify themselves on the blue sheet. Would be great.
They probably can't see the blue sheet, so maybe they could just tell us who they are.
Good idea. Oh, I see call-in user 8 dropped off. Who's call-in user 4? Maybe Andrew S?
I would assume it's a person that is only dialed in and has not done anything else.
Yeah, that's why it looks like be Andrew Sullivan.
Yeah, they probably don't even know they're caller user 4.
Andrew, are you call-in user 4?
I
One way we
commented
could
in the WebEx chat. I think I am.
Okay, perfect.
we could ask anyone that's just dialed in through the audio bridge, not through the full feature-rich kind of WebEx client or through WebRTC to check or to do a roll call.
I don't know what you mean by that, Roman. You want me to do a roll call?
No. So I think the outliers are the calling users. So if you participated in the working group meeting by just calling a phone bridge or a SIP bridge and did not use the WebEx kind of client, if you speak now, we can make sure that you're in the blue sheet, because everyone else we know because they're listed in the participant list by name.
So we did catch the call-in user 4. Call-in user 8 isn't on anymore.
Okay, well then we're done.
Next time. Okay, so just a reminder, our next virtual meeting will be on April 28th at 7 a.m. Pacific time. And I forget what time that is in UTC, but we'll send a reminder before the session. With that, unless there are any other comments, we can close the meeting. Going once, going twice. All right, thanks everyone.
Thank you, bye.
Thanks, Nancy.
Bye.